Alright, hi guys. Today we're doing 1.4 notes, and we have talked about, well, we haven't, but you have probably talked about area and perimeter quite a bit in different classes, in your different math classes. I've got a list of all the different names of polygons based on how many sides they have, and so, you're used to a three-sided figure is a triangle. A four-sided figure is a quadrilateral, and we have special kinds of quadrilaterals, right? We have squares, rectangles, trapezoids, a rhombus, and so there's different kinds on this guy that I want you to be aware of. They're all still quadrilaterals: pentagon, hexagon, heptagon, octagon. Nonagon is a nine-sided figure. A decagon is a 10-sided figure. There's a name for an 11-sided figure. We're not going to need to know it. A dodecagon is a 12-sided figure. And it kind of jumps to this N. Oops. It kind of jumps to this N. What this means is you can call any figure after that. If you've got like a 13-sided figure, let's say a 15-sided figure, we're just going to call that a 15-gon. Okay, so whatever number sides it has, you can just replace N with that number. Definitions you need to know: concave and convex figures. A concave figure is a figure that like caves in, is the best way that I can describe it. So if I've got something like this that caves in, where I could connect, I could connect this vertice and this vertice with a line. And if I can connect those vertices and there's one inside the figure, then it's considered concave. Convex is what you normally think of as just like a regular sided figure that doesn't cave in at all. Okay, so got the perimeter and area formulas listed here, so you're going to have to reference these. Composite figures is what you're really going to be dealing with in your assignments, and that's really just a figure made up of various shapes. And so you might have something that is made up of maybe looks something like this. Let's see. I'll erase this. And I could draw in, I could split this into two things. I could split this into a triangle and a rectangle, and we'd have to find the area and perimeter of that. Really, the big key that I can give you on how you're going to apply these formulas today in your assignment is that you are going to have to find the length of some of these sides of some of these figures in order to find the area and perimeter. And so remember, length, I spelled that wrong. Length is the same as distance, and we learned about the distance formula in 1.3. So remember, distance, you need 2 points, so you need x1 and y1 of one vertice and x2 and y2 of another vertice. And to find that, we use this long formula. Remember, x2 minus x1 squared plus y2 minus y1 squared. And so as long as you can remember that you're going to need that in order to find perimeter and area, you should be good to go. And I'm not going to go over a ton of examples like that, because I think once you know that really if it gives you a graph or it gives you the points of figures and it asks you to find the area or perimeter, first you've got to find the length of each side using those points. Okay, so I'm going to end the video, and if you've got questions, pop into my Zoom meeting or let me know and we can talk about it on the next class that we have. But you do have a assignment for 1.4 and an exit ticket quiz that you'll need to take for this as well. I'm going to extend the date on that exit ticket though, so It won't be due until the middle of next week, but the exit ticket for 1.3 is still going to be due on Sunday night. So make sure that you're understanding the use of the distance formula in order to do these problems. Alright guys, we'll talk to you later.